Hello friends, and welcome to a lecture on operation research. Today we learn how to solve a minimum spanning tree problem in Microsoft Excel. Stay tuned, we'll be using solver add-in, which makes it almost automatic to solve this problem. And it reduces the cumbersomeness and the rigor of actually solving it using paper and pen, and we'll be taking a fairly complex network to do it. I'm Professor Arvind Prasad. Okay, so let's start. Let's not delay our work. So here I go with my Microsoft Excel spreadsheet. I have opened it and the network is also on your screen. Now let me expand it a bit. Let me zoom it. So there we are. We have zoomed it. So this is your network. And as you can see here, we have node O to start with. And from O, you have nodes A, B, C, D, and E. So D and E, you have two nodes where you could possibly call them the end nodes. And O, of course, is the origin node. So how do you find the minimum spanning tree of such a network? Now, that makes it a pretty complex problem and a pretty interesting problem also. Whenever you use paper and pencil, it's going to be a bit cumbersome when you have these kind of networks, because there are a lot of interconnections in between the nodes which are in between the origin and the destination, which you call the intermediate nodes. So that makes it a bit tricky, that what should be your next logical step in movement. Now, the way I'm going to set up the spreadsheet here, that has already been discussed in one of my previous videos. So the link to that is given on the top right. Okay. And you will also find it below. Now, stay tuned. Even if you haven't watched that video, this video describes the way it's going to be solved. Only if you want to further understand the logic, okay, the logic that Excel ends up using in solving it up, okay, the algorithmic logic, then of course, I would definitely suggest you to go and have a look at that video. So now, first what we do here is, I'll just move this chair. It makes me a bit uncomfortable. Yeah, right. So the first thing that we do here is, let me show this network once again very clearly to you. Okay, there we are. So this is your network. And the first thing that we do is we make note of the arcs. So the arcs, always, as always in networks, they start from a node and they go to a node. So now what are the arcs we have? We have arc O and it goes to A. Then of course you have node O, it goes to B. So you have OA, you have OB, you have OC, so that you have O and then you have C, right? Then afterwards, looking at this critically is very, very important. You have OD, right? So there we are, we have O and we have D, okay? Then afterwards, OA, OD, OB, OC. Now we come to A. So we start with A now. Now from node A, we can directly go to node B. Further from node A, we can go to node C. Okay. So from A, you can go to B. From A, you can go to C. And from A also you can go to D. So from A you can also go to D. Right? So we are done. Let's have a look once again. AB, AC, AD. These are the only possible ways you can go from A. So these become your arcs automatically. Now we come to the node B. Now from node B, what are the arcs we have? From node B, the arcs that we have is B to C. Okay, so from B we can go to C, then from B we can go to E. So from B we can go to E, right? Those are the possible directions we have. Let's have a look once again. From B, we can go to E. From B, we can go to C. Right. Now we come to node C, and the arcs that we could have from here are C to D and C to E. C to E. Okay. Right. So do we have B to E? Yes, we have B to E. So 2 coming in. D, you have 3 coming in, 1 coming directly from O. So let's check out with D. So we have D here. D is being approached from A. D is also being approached from C. And okay, 1, 2, and D from C also. So we have here OD, we have AD, and we have CD. So we have pretty much all the arcs. Let us count all the arcs here. The number of arcs here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what we have here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So we have made a note of all the arcs. Now make a note of the distances or the lengths of the arc. So we have the distance here. Now OA is 1. Now OB is 5. Now OC is 7. Right? Now OD is 9. Okay. AB is 6. AC is 4. AD, that is A to D, this is 3. So all these distances are in kilometers. Now then we come to B. So BD, BC is what we have as 5. So BC is 5. And then BE, that is from B to E, we have 10. And then from C to D, that is C, here we have C to D, we have 8. And C to E, finally, we have C to E, we have 3. So we have made a note of the distances now. Now we define something which is known as en route, R-O-U-T-E, en route. So we first fill in zeros here. Now the total distance, okay, or the total length, whatever you want to call it. So total length is going to be nothing but en route, that is sum product, then en route and distance. So it is the product of the en route and the distance. So what does sum route do is basically it takes 0 into 1 plus 0 into 5 plus 0 into 7 plus 0 into 9. So supposing we have selected an arc, let us say we have selected arc OA. So its en route value, we take it as a binary, is going to be 1. So therefore, the distance we are going to 1. Now let us say, supposing a hypothetical situation, BE is also one of the arcs that is selected in the minimum spanning tree, and let us call it as 1. So the total distance becomes 1 plus 10, and that makes it 11. Now, what is the arc sum? Okay, we define something which is known as arc sum here. Now the arc sum is going to be nothing but it is going to be the sum of all the arcs. Okay, remember one thing, you have only zeros and ones on en route. So it will sum up only the ones, right? There we are, it is 2. Now, if we have a problem, if you have a problem in a network which has, let us say 1, 2, 3, 4, 5, 6 nodes. So the minimum spanning tree is going to be with 5 nodes. You will have, you will have 5 arcs in it. Okay, you will have 5, it will be a 5 arc solution. So the minimum arcs that are going to give your solution is 5. So we have 3, 3, 6, and that's 5 now. Now we are pretty much done. We now know that if you have some automation in Excel, well, the correct routes which are a solution to the minimum spanning tree are selected and they are put as 1, you get the total distance. And remember one thing, they cannot be greater than 5. Okay, those selections cannot be greater than 5. Now, how do you do it using solver? That's the entire question now. So what we do here is we first define our nodes. So the nodes that we have here are O, A, B, C, D, and E. These are the nodes we have. Now, in. Okay. So we define something which is in. That is in a particular node, in is nothing but it's in a particular node. What are the arcs entering in? And out is nothing but in any particular node, what are the arcs leaving out? Okay. So the arcs coming into the node is going to be sum if. Now we are going to take 2 because that's going to be the direction. You have a node here. The arc is going to come to the node. So that's going to be one which is coming in. Comma, select the node and comma en route. Okay. Now complete the bracket and make these absolute references. So for this we do function F4 and for this also we do function F4. Now what does this do? Remember? Okay, now what will it do? Now supposing if something is, any arc is selected, okay, which is entering a node, automatically its value, en route value is going to come up here. And supposing multiple arcs have been selected entering a node, so it's just going to it's just going to get added up. We are going to get the additions here. Now let's go to out. So it's sum if out. So out is going to be from, comma, node, comma, en route. That is it. Function F4 and function F4 to make it absolute. Function F4. Now we are done with it. So as we can see here, the node going out of A is OA. Now let us say supposing I also selected OB. The addition would be 2. Okay. Now what we do here is we take the difference. DIFF. Okay. We take the difference of the nodes entering in, arcs coming to the node. We are taking the difference of the number of arcs coming to the node and the number of the arcs leaving the node. Okay, there we are. So now the ones which are entering in will be negative and the ones which are leaving out will be positive. So out is going to be 2. Okay, in this case, out minus in. Now, this is a usual convention used in the solving network problems. Even when you're solving it using paper and pen, you'll find that this is the convention which is used. That is, the arcs which are leaving the node are taken as positive and arcs which are entering the nodes are always taken as negative, right? So what we have here now is we have taken the difference. Now let's select this and bring it down here. There we are. And let's select this also and bring it down here. Okay, we are done here. We are pretty much done. Now, remember, the only restriction that you have to put here is that there should be minimum 1 arc entering D and 1 arc entering E. Okay, because we have to include these nodes in our minimum spanning tree. So at least there has to be 1 arc which is entering this here. That's because in a minimum spanning tree, as you know, you have a path which connects to all the nodes. Okay, and that path has the minimum length. Okay, so the difference, okay, from O. Remember, multiple nodes cannot emanate from O also. So therefore, it's going to be 1. The difference is going to be 1 here. And the difference in case of E is going to be -1. And the difference in case of D is also going to be as minus. So these are the constraints that you have to put on this. Okay. So these would be the constraints that you have to put. The rest of the constraints are free. They will be automatically getting selected. You may have in the rest of the nodes multiple arcs coming in, few arcs leaving out, one arc coming in, one arc leaving out, or just one arc coming in but no arc leaving out. Okay. So that's it. So now we are pretty much done with setting up our spreadsheet and putting the constraints, right constraints in the place. Now let's go ahead and solve the problem. Okay, to solve the problem, let me first save my work. After that, you go to data. After you go to data, you go to solver. Okay, now let me drag the solver window up. So the entire idea is in the minimum spanning tree problem is you have to minimize the total length of the spanning tree. So it's effectively like saying that you have to minimize the total distance. Okay, so we select the total distance and you need to minimize it. You have to minimize it by changing the on routes. Now, this is something I'm not going to explain it once again because this is already discussed out. Okay. Now, subject to the constraints. Now, the first constraint that you're going to have is that the arc sum, it has to be equal to 5. That's the first constraint you're going to have. Okay. So that's the first constraint is something we have entered in, right? So that's your first constraint you're going to have. Now, the second constraint that you're going to have is that this difference has to be equal to 1. Okay. So let's go to add once again and let's take this difference. Now, this difference has to be equal to 1, right? Add. Then afterwards, this distance or this difference rather has to be equal to -1, add, and of course at the end this difference also has to be equal to -1. So let's have a review of the constraints that we had. The review of the constraints is the first one, that is D20 equal to E20. So that is the arc sum should be equal to 5. Then you have J11 is equal to K11. So you have J11 is equal to K11. Then you have J12 is equal to K12. Yes. And you have J7. This is the J7 one equal to. Now remember one thing, in the on route, you can have only binary values. So that's also one of the constraints. The on route values can be only either 0 or 1. So that is one last constraint that we have to enter. So let's go to add once again and let's select the entire on route cells. Once we have selected this, you go and you say it's binary and you click add. You are now pretty much done adding all the constraints. So cancel. We are done with adding all our constraints. We use the simplex linear programming to solve it out and click solve. And as you can see here, it is solved. Yes, the answer is 16. Right? Now let us discuss what is the minimum spanning tree and has it really given you the minimum spanning tree or not? And can you use this spreadsheet to find out what is the minimum spanning tree solution? So the solution is the ones are the arcs which have ones are a part of the minimum spanning tree. So what we have is O-A, right? So OA has 1, then AC, AC, then you have OA, then you have AC, right? OA, then you have AC, then you have AD, right? So OA, AD, AC, then it's but natural what you have after this is BC. So BC, OA, AD, AC, then BC. Okay. After BC, finally what you have is CE. CE. That's it. I'm not going to draw and demonstrate to you that this is the minimum spanning tree. You can take a paper and pencil and just look at this solution, work out this solution on a spreadsheet, watch my video and draw it back. And you'll find that yes, this is the minimum spanning tree, which has a length of 16. Remember, the arcs are 5. You have to use, since it has 6 nodes, there should be only 5 arcs. Only 5 arcs have been selected here. And that's the justification of the solution. And of course, the other constraints that you have put up here, there is only one node leaving O. There is one node entering D. And there is one node entering E. That's all, my friends. I would always suggest that since this is a very simple algorithm which has been put forward to you, to all my viewers, I would just suggest that take up problems from various sources and rigorously test this algorithm. Okay. And if it fails, do let me know in the comments. I would be only happy to receive them and analyze. But of all the tests that I have done, this algorithm works perfectly well. It uses solver add-in, which is quite popular in Excel, and it is available whenever you have Excel. It is, interestingly, a solver add-in is also available to you in LibreOffice, which is the Linux equivalent of Excel. Of course, LibreOffice can also be downloaded in Office and you can use it. So you can say it's an alternative to Microsoft Office. Okay. Even that has this add-in and it works the same way as it is demonstrated here. So that's it, my friends. Have a great day. Have a great time. Do subscribe my channel and do share this video to everyone who would be interested. You can take fairly complex problems and solve it this way. Goodbye, friends. Have a great day and have a great